Hi, this is Gabriel, and what I would like you to do right now is to sign into YouTube so that if you like this channel and you're like, oh, dang, this is pretty good, I want you to subscribe to this channel and you're not all like, I have to sign in and I just have to hit the subscribe button. All you have to do is just hit subscribe and you're subscribed. That will save you hundreds of milliseconds. So I want you to watch this channel from beginning to end so that you get the most out of this walkthrough.
Hi, it's Gabriel, and today we're going to walk through this particular problem. We're going to have this problem, f of x is equal to x cubed plus f of x minus 7, and we are using Newton's method to approximate the root of this particular problem. So this is Newton's method. I don't know how to spell Newton. Newton's method. And the formula for Newton's method is just this. X to the n plus 1 is equal to x to the n minus f of x, f of x to the n, divided by f prime of x to the n. So essentially, x to the n goes here, here, and here. So in our case, this x to the n will be this one. And if you were to graph this in a graphing calculator, it would look something like this. So a root is just basically that point right there. So that would be a root. It's an x-intercept. And what we want to, using this particular method, we could approximate that using this formula. So it's kind of like a neat little trick where if you wanted to approximate, let's say you were in NASA and your computer for some reason didn't do anything more than 8 decimal places and you wanted to be really precise, you'd use this, basically. And this is how it works. I'm going to find, if they give me 1 here, I'm going to find the next biggest number. So I'm basically finding x to the second. Well, x to the second is going to be equal to x to the 1 minus f of x to the 1 divided by the derivative of x to the 1. So everywhere where you see x to the 1, I'm going to plug in a 1 because that's what they gave me. They said x to the 1 is equal to 1. And this represents this equation here. So we also need to find the derivative of f of x. Let's go ahead and do that. The derivative for f of x is going to be equal to, so I'm going to write it down over here, the derivative of f of x would equal to 3x squared plus 5. And that's it. And I also need my original equation, f of x is equal to x cubed plus 5x minus 7. And what I'm going to do with those two results is I'm going to divide whatever I get from here divided by whatever I get from here. So my points that are going to go in here are going to be A1 for the first run. So what would I get? Well, 1 plus 5 is 6, minus 7, I would get that f of 1 is equal to negative 1. F prime of 1 would equal to, this is 3, because 1 squared is 1, 1 times 3 is 3, plus 5, that's, what's 3 plus 5? 8, right? So So that's going to be an 8. So now I could figure this x of 2. So x of 2 is going to equal to x of 1, which was this one over here, 1 minus the division of these two. Right? I'm going to divide this by that, which is a negative 1/8. Well, if you plug that into the calculator, it approximately becomes 1.125. In fact, it's exactly that, because it's these would all be zeros. But we'll just say it approximates that, x of 2, because that's gonna be what it typically happens. Now, what do we do with that? Well, for this particular example, I wanna find x to the x of 3, and I wanna round to 4 decimal places. So I'm going to go ahead and use the equation one more time and say, so now I'm going to rewrite this equation now, but now instead of having a 2 on the outside, I'll have a 3. So I'll have x to the third is equal to x squared minus f of x to the second divided by f prime of x to the second. So it's essentially this, except these subscripts got 1 bigger. And that's why they write it like that, because this equation is gonna be repeated like this. Well, what is x to the 2? I know what x to the 2 is. It's this number right here. So that's what's gonna go into my f of x. Instead of now plugging in 1, I'm going to plug in 1.125. 1.125. 1.125. 1.125. And I'm also going to plug in that 1.125 into the derivative. So I'm going to have 1.125 and 1.125. Is equal to that cubed plus 5 times the number minus 7. Then this is going to be the derivative. It's going to equal to 3 times this number squared plus 5. Well, if you plug all of this into the calculator, what you should get is this is going to be, I already calculated over here, and what I got was, if I cube this number, I get the result of this is, I'm trying to find it over here. Oh, there it is I get approximately 0.04882812. That's it. I know, it's pretty big. And what I get from over here is 8.796875. And I have to divide those two numbers, and the formula is going to look like this. So what I did before is I plugged in x of 2, which was 1.125, minus the division of these two numbers, 0.04882812, divided by 8.796875. And the end result that I get from that is 1.119449. Except if I wanted to round up to 4 decimal places, well, my 4th decimal would be 1, 2, 3, 4. This one right here. So I go to the next one. Since 4 is less than 5, this is going to stay at 4. And my answer is going to be x to the third, or x subscript 3 is approximately 1.1194. And if I look at the graph, yeah, it kind of looks like it's there. So I know I did it right. Well, that's another walkthrough. Hopefully you liked it. And if you would like to see more, go to mastermathcourses.com and you can ask a question there.
So that wraps it up. And if you haven't signed into YouTube, oh my goodness, you're going to have to waste hundreds of milliseconds. But don't forget to subscribe to this channel. Just sign in, dude. It's worth it. It's worth your time. You can ask a question. We could follow up with another video.